Checking brushless motors to see where they conform with the rules is a very difficult task, especially if you're trying to see if somebody is cheating or not. Because if you try, you can only measure certain parameters. If you've got a 10.5 turn motor and you want to know whether the stator is exactly 10.5 or whether they're using a short stack or whatever, or some mess around with it, it's very difficult to do unless you have a very good meter. Now, people say of testing that they can use an inductance to measure the inductance of a motor. Well, this is very difficult to get an accurate inductance reading on one of these motors because the strength of the magnet on the rotor will affect the results, as well as your meter. If it's got any, if it's not very well made, it just will not read properly. It'll be all over the place. Even this one is quite expensive. An LCR meter will have trouble reading these motors dead accurately unless you're very careful with attaching these probes, and you have to make sure you set the frequency always the same. They don't like reading low frequencies if you've got very low inductances, so you'll have to up the frequency on this to 1 or 10 kilohertz. A better meter would be this much more expensive mains operated one. It's a digital bridge. Well, that's a bridge too, but this is a more sophisticated one, much more accurate the way it does the testing, and it will measure your resistance capacitor and inductance the same as this one, but it is much more accurate the way it does it. It's more sophisticated circuitry, and even so, you try and check a motor, but if the magnet has gone weak, you'll get a different inductance reading. So if you're trying to find if somebody is using the proper motor, you're reading what you measured on a brand new one is not going to be the same. With the inductance meter, you can connect these probes. I've got as an example, this is an old 10.5 motor, and I don't know if I can zoom in for you. Try and zoom in a bit and read this. Inductance 26 microhenries on that coil that I'm measuring. You can't see it in the screen. I've got it across one of the coils. If I turn the magnet, the inductance is staying, goes from 24 microhenries, and then it can in one place it go up 25, 27. So there's even a variation depending on where you put if the magnet has gone a bit weird. Anyway, say that's about 24 microhenries, and this is another 10.5, almost the same motor from the same time, and it's reading 26 microhenries. But then if you take, there's a quite old motor, if you take a new BRCA legal 10.5 motor, these have been much improved now with the winding quality of the laminations, quality of the wire, and it's only 19 microhenries now. Let's turn the magnet So what we're going to say is this legal and that not legal. That's a big variation from 25 down to 19 microhenries, and that's measured at 1 kilohertz. This will measure at 10 kilohertz, the same. And then if you check, same with a 13.5 turn motor, a modern one, (32 microhenries), 33. So all you can say is that it's a higher wind than the other one. Also, if you have the coil out of with no magnet in the middle, you'll get a totally different reading. Now this is a 17.5 turn stator, and that's reading 91 microhenries across one of the coils. We can put it across the other coil if you want. 92 microhenries, and we can check the other coil to about nearly 92 microhenries, so it's very accurately made. But if you take the same motor, 17.5, with the assembled and measure the inductance, it's dropped to about 50 microhenries. And if I turn the rotor, it's gone to 54 microhenries, 53. So the rotor makes an effect where it is. But I mean, it's so much different. I've got another one here as well. This is also, this is a 17.5 Trinity again. This one's not new, it's been used, and let's get a connection, hopefully. In one position the magnet's reading 63 microhenries, and in another it's 55 microhenries. 62, 56. So that one's all over the place. So you can't actually know what you're measuring, checking the microhenries. The only way you can do it properly is by measuring the resistance of the coil with something like this meter here, a low ohm meter, because the coil resistance will not change except with temperature. So assuming it's not very cold, or you're not measuring the motor when it's hot, you'll get the same reading all the time. And if I just unzoom this on the meter here, I've done lots of measurements with this meter, and I've made some notes on the on here, if that focuses, of motors, what their standard coal not being used resistance is. And this meter, there's a specification, can measure from 0.001 ohm to 200 ohms in 0.001 ohm increments. Now and the accuracy is 0.1%. You can't use a normal multimeter you buy in the shop. They normally, anything below about 10 ohms, it'd be so inaccurate. And we're measuring here on the 10.5, 0.020 of an ohm on a coil. And you can see I've also measured them hot to show that how the resistance, which is normal Ohm's law, when they're hot, resistance goes up. Got a 13.5, 10.5, and the 17.5 is 0.045 ohm. and you can measure even this 2.5 are measured, the 0.005 and the 65.010. So with this meter now, if I turn it on, can you see that? I'll try and zoom in a little bit so you can see it. It's blinking at the moment. Now if we do the same test now on these motors, the old 10.5, I'll try and if I put that back in there, it won't fall down. I think you can still see it, can you? Almost. Just move it forward a bit. Yeah, you can see that. The old 10.5 motor from years ago measures 0.020, or just under, and then the new 10.5 motor, which gave a totally different inductance reading, 10.5, measure the coil, 1819's better because they've probably wound with a better wire, and they've wound it a bit tighter just to get the resistance down a bit, but it's still very, very close because that's a 10.5. Then if you take, for instance, actually be easier to do it on this one, 17.5 stator, .045, and as I showed you earlier, the reading I had as a reference 0.045. Now that's a stator on its own. And then if we take a 17.5 whole motor and connect the coil, 0.045. So when we measured the inductance, the two inductances were totally different, and also the old, this is the used one, had a different inductance again. And it's slightly higher, it's probably a bit better. So it's not even as good. It's 0.047. So let's try and get another coil too. So that one isn't even as good, but it's close enough to the 0.045 for those motors. And so the resistance way is the only way you can do it. If you try and use inductance, unless you take the motors apart and measure the stators on their own, it's just a nightmare. But as I said, you can't use a cheap multimeter. You've got to buy a specific low ohm meter.